Hi. So we've finished teaching you all of the topic of physics, and you've probably just done a test as well. So you're thinking, what's next? Why would we carry on learning? Well, one, this is still school time, and two, it's not all about the tests. Part of your assessment for the GCSE is that you have to complete a series of experiments, and these experiments we have to sign you off that you complete these experiments, and also you just have to be prepared to answer any questions on these experiments. Obviously, we're not in school, so it's difficult to do the experiments, but what we can do is try and recreate one for you from the comfort of your own home. So over the next 3 lessons, we're going to kind of plan the experiment, do the experiment, and analyze the experiment. When I say we, I mean me. I'll do all these things, and you just come along for the ride. So the aim of today is to be able to describe the standard practical procedure for determining the specific heat capacity of a material. But let's start off with some questions. Name 5 different types of energy. State 4 words to describe how water can change its state when its temperature changes. Give me 3 equations for energy, and what is the difference between energy and temperature? Pause and answer the questions. Write down your answers, and then I'll give you the answers in just a moment. Have you done? Splendid. Let's get this pen working. 5 different types of energy. We've got, obviously, kinetic. We've got thermal. We've got gravitational potential. We've got elastic. And you could say something like chemical. Nice. Describe words how water can change its state. So if we put it over 100 degrees, we boil it, which is the same as evaporate. We can freeze it. And the opposite of freezing is we can melt. And the opposite of boiling and evaporating is condense. 3 equations for energy. Ooh, the kinetic energy is half mv squared. Gravitational potential energy is mass times height times gravity. And elastic potential energy is half kx squared. What is the difference between energy and temperature? Well, for thermal energy and temperature. So thermal energy is, if we remember rightly, all things are made of particles. And those particles vibrate at a bit. As long as they're not at absolute zero, these particles vibrate. If we add up how much vibration they each have, that is their total energy. Total energy. All of the individual particles. Temperature is looking at the average energy of those particles. So, for example, if something's very hot, those particles will all be moving very fast. Their average energy will be quite high. The total energy, that totally depends on how big the thing is. If the thing has a lot of particles, even something very cold can have a lot of energy. If the thing has a few particles, it won't have much energy at all. So energy is just how much energy each of the particles have. Temperature is basically what is the average energy of those particles. If they have an average that have a lot of energy, then the thing is hot. Average has a low energy, things are cold. So this is the basic experiment. If you're in school, we would do this. Now I'm going to do a version of this in tomorrow's lesson that we don't have this equipment, so I'm just going to have to do it with a kettle and other things. But if we were in school, we would do this. What we need to do is we need to work out the energy required to raise the temperature of something. And we're going to use the equation at the bottom. Energy is equal to mass times specific heat capacity times temperature. Now, this thing here is called a joule meter. You plug it in to a power supply. It tells you how many joules it uses. That is the best cheap method we can use. There are other versions too, but this is the best cheap method we could do. And what you do is you plug this joule meter into your power supply. It's my power supply here. And both of these things go into a little immersion heater. A little immersion heater is when you put electricity through it, it gets hot. The simplest thing would be like in the bottom of your kettle, those kind of pieces of metal, they are like an immersion heater. Put electricity through them, they get hot, they heat water or other metals. This is the material, aluminium, that we're going to heat up. And here is my thermometer. Also, it has been wrapped in some insulation. So what will happen? Well, let's read this. Objects of the same mass but made of different materials need different amounts of energy to raise their temperature by the same amount. Each material has its own specific heat capacity, which tells us how much energy is needed to raise the temperature of 1 kilogram of that substance by 1 degree. Equations for calculating specific heat capacity from energy and temperature is energy is mass times specific heat capacity times temperature change. So we plug the thing into the joule meter and we record how much energy is given. We look at the temperature using the thermometer. We can record the temperature change. So if it say starts at 20, finishes at 25, the temperature change is 5. And we know the mass of the object because we will put it on scales. So we put in energy. Energy is put in. The temperature will change. So we put in the energy and we will watch the temperature go up and we'll record that temperature go up, that temperature change. The mass, that stays the same. That's not going to change. And using those things, we rearrange the equation. Energy is equal to energy over mass times temperature will give us specific heat capacity. And that's what we do. But we can't. But let's just get your brains working. What is the name of the piece of equipment that you would use to measure the following variables? I want you to use the correct scientific name, not terms that you might use at home. Like, for example, you were measuring the volume of liquid. Some of you might say a measuring jug. Measuring jugs for cooking. You'd use a measuring cylinder in science. But how would you measure the mass of a material, the temperature, the voltage, the current, and lastly, the energy? I put a question mark there because you may not have used one, but I have spoken about it. So write those down. And then the answer. Here's a little summary of the variables just to remind you. What you change is independent. What you measure is dependent. What you keep the same is control. So if you're changing something in the experiment, that's the independent. If you're growing plants, it might be the amount of water. That would be the independent variable. It could be the amount of sunlight. The independent. What you control is the independent. Then the change that happens, that's what you measure. Again, for plants, it could be how much they've grown. What you measure is dependent. Some things in an experiment shouldn't change, otherwise the experiment is not fair. It has no standing. So some things you have to keep the same. They are the control. For example, if it was the growing plants one, it should be in the same soil or same amount of other things in the air. Can you remember? I'd suggest write them down. Help you remember. Got it? So in this experiment, what is the independent experiment? A variable in our experiment. If we were going to do that experiment, the one with the joule meter, what's the independent variable? What did we change? What is the dependent variable? What did we measure? What was different? What was happening in the experiment? And what were the controls? What should be kept the same? Sometimes there's more than one. Pause and answer the question. Done? Splendid. Here we have two important definitions. Not really definitions, just representations. Accuracy and precision. Things can be accurate, things can be precise. They can be neither accurate nor precise, but do we know what they mean? Okay, so here is a little pictures showing this first one. The target hitter is not very accurate, but they are precise. The second one, they are accurate, but they're not precise. The third one, they are neither accurate nor precise. And the fourth one is both precise and accurate. Accurate is, does it hit where it's supposed to hit? Does it get the right result? If you're trying to aim for a target, does it hit the target? Accurate is, does it achieve what we want it to achieve? Precise is, do you get the same thing happening again and again? So here we have the person who's, say this was arrows, they fired 6 arrows. They all end up in exactly the same place, the same group. That is very precise. It's not where we wanted them. They've missed the target, but it's very precise. If you're a footballer and you take 10 penalties and you each time you go to the left of the post, you could be precise. It's not very good, but it's precise. If we can, all the results end up in the same place, that is called precision. Accuracy is where they end up in the right place. So now if we look at this one here, this piece hits the target. So that is accurate. But all the other ones are quite far away. And they're not all grouped together. That is not precise. This one here, all of the points are very far apart. They are not precise. And none of them hit the bullseye. So they are not accurate. So you can be not accurate and not precise. This last one, this person, some sort of target genius, has managed to hit the bullseye every single time, and all of the shots are very close together. They are both precise and accurate. If you're accurate, you hit the target. If you are precise, you keep hitting the same place. So, just test yourself. Can you say whether A, B, C, and D are accurate or precise, or both, or neither? A is, then A, B, do accurate, precision, accurate, precision, accurate, precision, accurate, precision, and then true or false, or yes or no. So for each of those, you need to tell me whether they are accurate or precise. Pause and answer these questions. Okay? So now, hopefully, in the task earlier, you wrote down the list of the pieces of equipment that we might use with our experiment. Can you write down those pieces of equipment in this table form? And can you work out how you can make them to be accurate and how can you make them precise? So for example, I'll give you an example. If you want to measure something accurately, you make sure you zero your digital balance is the proper name for the scales. Make sure you zero your scales. Okay, make sure you zero the scales so you're only measuring what you put on it. How can you be precise? Well, a lot of these things is about repeating and check you get the same answer each time. If you don't, do it again. What else do we use? Can you think about how you might be accurate? How you might be precise? Fill that in. Okay? Right. Let's complete the following paragraph by circling the correct word or phrase from the underlying options. So you need to write this out, but only write in the correct parts. While the heater is switched on, energy is transferred from the heater or to or from the heater to or from the block by a force or heating. The temperature of the block decreases or increases. The amount of energy transferred is measured using the thermometer, joule meter, and the temperature change of the block is measured using the thermometer or joule meter. Select the correct options. Okay, that is a good place to leave it. Tomorrow, we'll do the experiment. So you'll need all the things that you've done today for tomorrow's lesson. Okay, love you, bye.